This will make it a lot easier to solve circuits on the MCAT. We're going to look at 3 common examples to help you find the equivalent resistance. Anytime you're doing this, look for 2 resistors that are very clearly in parallel with each other or very clearly in series with each other. For example, if you tried to do that with this resistor here, it can be confusing to some people because they might say that it's in series with this one, but it's also in series with this one. Some other people might think that it's in parallel with this one right here. My recommendation is that anytime you start to get confused, look for other resistors that are simpler to think about. The 2 easiest resistors that we have to work with here are these 2 because they're clearly in parallel with each other and they're not in series or in parallel with any other resistors. Now we can apply the equation for parallel resistors really easily. 1 over the equivalent resistance is equal to 1 over 4 plus 1 over 3. Find your common denominator for 4 and 3, which is 12. So we have 1 over the equivalent resistance is equal to 3 over 12 plus 4 over 12. So then we have 1 over R is equal to 7 over 12. R is equal to 12 over 7. That's going to be fairly close to 2, but a little bit under, so we're going to say that R is equal to 1.8. Now we can erase these 2 resistors and redraw it as 1 resistor with a resistance of 1.8. The circuit now looks super easy because we have 3 resistors that are very clearly in series with each other. We apply the equation for resistors in series and just add these up. 1 plus 2 plus 1.8 is equal to 4.8. We can redraw this entire circuit as a circuit with 1 resistor that has a resistance equal to 4.8. Apply the same thinking to the next circuit and again look for the resistors that are really simple to solve. If you pick these 2, they are very clearly in series with each other and not in parallel or in series with any other resistors. The equivalent resistance is just equal to those added up, so 1 plus 2 is equal to 3. Now erase those resistors and replace them with 1 resistor with a resistance equal to 3. Do the same thing for these resistors and you get 1 resistor with a resistance equal to 7 ohms. Now we combine these 2 since they're in parallel with each other. We do 1 over the equivalent resistance is equal to 1 over 7 plus 1 over 3. The common denominator would be 21 and we get 3 over 21 plus 7 over 21. That's equal to 10 over 21, so the equivalent resistance is equal to 21 over 10 and that's roughly 2. Then we combine our 2 resistors to give us 1 resistor with a resistance of 2. On the last example, apply the exact same thinking and choose 2 resistors that are super simple to solve. You could pick either these 2 resistors or these 2 resistors, so let's just solve both of those. The top ones combine to give us a single resistor with a resistance of 5 because we just add them up, and the same goes for those middle resistors. Now hopefully you can see that these 2 resistors are very clearly in parallel with each other. For this we do 1 over the equivalent resistance is equal to 1 over 5 plus 1 over 5. That's equal to 2/5. The equivalent resistance is equal to the reciprocal of 2/5, which is equal to 2.5. We erase those 2 resistors and make a single resistor with a resistance equal to 2.5. Finally, we just add these 2 together since they're in series with each other, and that gives us a final resistance of 7.5.